Good morning, everyone online. Can you hear me? Yep, brilliant. Thank you. Okay, share screen.
Oh, David's been having problems logging in.
Is David there?
No, he shouldn't be.
Yes, that's what I'm
Right, let me come up.
Right, we are ready to go. Apologies. So at this point, it is standard for me to make a joke about how we want artificial intelligence to help us set up talks and things and make Zoom work for us. So everyone should be able to see my slides. You can certainly see them in the room. I think you can see them online. Jacob, can you in the... Perfect, thank you. So good morning, everyone, and welcome to Plymouth. It's very nice to see you all here. It's very nice to be able to be here with some of you this year. My name is David Walker, and I am a lecturer in computer science here at Plymouth. I teach on a number of subjects, including web development, but also including artificial intelligence, which is what I'm going to talk to you about today. Excuse me. So what we'll talk about is today a specific aspect of artificial intelligence. I'm going to talk about how we might make machines think and how we might tell that the machines are thinking themselves by how well they can understand what we're saying. So back in 1956 or so, a group of academics started off a summer project, and the summer project was, we've got these machines. They were mechanical computers. They certainly weren't anything like the sorts of devices we have in front of us now, but they were computers, and they started off this project to say, you know, it'd be kind of nice if we could have machines that can think. And they had what we do in academia is you get some funding, you then go and do a project, and they got funding for this 8-week project that would be held in Dartmouth in the United States. And what they did was set out to solve how to create thinking machines. What they did was name the field. By the end of the 8 weeks, they decided it should be called artificial intelligence, but that was about as far as they got. They did, however, think of some key topics that should be addressed. So there were things such as how we organize memories, how we organize data basically in our heads, how do we process that sort of information, how do we think about doing computer vision tasks. So I can see people in the room in front of me, there's a lectern, there's some computers on it, all sorts of things. There's some stuff on the screen implying I'm giving a talk. There's a Zoom window. I can tell all of this because I can see it. And that's because my eyes and my brain work together to give me a very powerful, actually, vision system. And we do things like object detection, so I can tell where the seats are, where the people are in the room. Object identification, so I can see that Jacob is sat in the first row there. And my brain does all of this for me. Wouldn't it be cool if we had computing that did the same? And actually, we're starting to have that. We are starting to have computer vision tools that can do object recognition. When you upload a photo to Facebook, you have a number of things happen, one of which is it'll try and tag the people in your photo for you. It's able to do that because of the vast amount of data that we've given it, and it's had lots of practice, basically. There's also a lot more computing power now than we had in 1956. One of the other topics that they came up with was this idea of natural language processing. So you are listening to me give this talk, and this is the sort of talk that I'll give repeatedly to different audiences. And when I'm giving this talk, what I'm saying will not always come out the same. So I'll always be giving a talk about natural language processing. I'll always be starting off by talking about Dartmouth conference, 1956. I usually throw out a computer vision example, and I usually make some bad jokes as we're going through. But exactly what I say on a word-to-word level will be different every time I do the talk. So I'll be coming from different contexts at the time. You know, I've been in different things that will have made me think about the talk in different ways. I've been teaching different bits, so I generally find I talk lots about the web in the first semester, in the autumn, and lots about AI in the second semester, and everything I do around it sort of has that feeding into it. So I won't give the same talk twice. We don't speak like that. That's not how we communicate as humans. What we do is use a approximately the same thing. So I'm giving the same talk, I'm giving the same information, I'm talking about the same things, and I'm doing it in literally different ways. I'm literally using different words each time. For a computer that is designed to program, parse data, do number crunching, all of that sort of thing, that is an absolute nightmare. So you have something that is going to expect, from a computational point of view, if two things are the same, they are literally identical. If I wanted to do this talk again and make it computationally the same in terms of the words I use, I would literally have to read a script. And that would be awfully dull, because I would be reading like this and it would come out very, very dry and uninteresting. So computers want everything to be exactly identical and understandable, and humans, I mean, some people can do it. I certainly can't. I can't speak in the same way twice. And that makes it very hard for the two to come together. And that's what natural language processing is designed to do. Make computing and able to interact with what we are doing and saying as humans. So that's what I'm going to talk about today. Next slide, please, as the phrase goes. So here is some words that say all the things that I just said. I'm normally at least a slide ahead. So what we want to do is have computing that can understand what we're saying, that can maybe generate language in the way that we use it. So if you think about your smart home assistants, if you have a popular, I'll do it because I've got people online and it's fun. If anyone's got an Alexa in the room, it's just gone off. They need to understand what we're saying. So I want to be able to say, Alexa, play me some music. And I want it to play the music that I say. What it often does is say, I'm sorry, I don't understand that, in a slightly irritating and vaguely computational voice. It's very, very good. It is a very advanced tool. There's a lot of cool stuff going on in there to make it work. And if you think back 10 years, it's not something we had. So Siri was, I think, pretty much the first example of this, and that came out about 2014 or so from memory. So 8 years we've had this. It's still really new. And I'll talk about why that timing is important a bit later. So we want to be able to understand what we say. If we think about, the robot uprising that we're probably desperate to avoid, and we want to have robotics working usefully in our everyday life, then they need to be able to understand what we're saying to them. You're not going to want to sit down and type something, or maybe, I don't know, we're talking typing really. That's how you interact with a computer. Maybe you have a mouse, maybe you have something like that, but classically that's the way that we interact. We don't want to be doing that with humanoid robotics or anything really that we don't have to. It's much more efficient for us to be able to say, I need you to do this in the way that we would to a person. Once we've said, I need you to do this, or we said, Alexa, play me some music, we then need to have a response. And those smart home assistants really were one of the very first things that didn't have a screen attached to them. So you get your, slightly sleek looking black tube, or a little squat white thing if it's another popular device. There are many of them now. They don't have a screen, so they don't have a way of printing out, I've done this. And in the example I've given, if you have a request for music, it's fairly obvious if it works, because the music starts or it doesn't. If it doesn't, you don't know why. So why hasn't this worked? Is the internet down? Is the command something it just didn't understand? Does it not have the music available? So you may have asked for something obscure. So we need some feedback. So I once tried to book a holiday and paid quite a large amount of money for the holiday, and then nothing happened. So the website stopped processing my card details, and there was absolutely no feedback. It didn't say, we've taken your payment, we're looking forward to seeing you in 3 months' time when you come on holiday. Nothing at all. And it turned out through investigating that it hadn't gone through. And I just said, well, I can't really be bothered with this. You've got a terrible system. I'm not giving you my business. We need some feedback as people, otherwise we assume something's gone wrong. And we need feedback to tell us what's gone wrong so that we can try and fix it. So we need natural language in the case where we don't have a screen, we don't have any other way of having that feedback, to present us some sort of message. I'm sorry, I don't understand that. And that's a useful message. Okay, I've said what I think makes sense, but it hasn't gone out properly. the smart home system has not understood it. You generally get, certainly with some of them, they will flash a certain color if the networking is down, but otherwise you need it to tell you what's wrong. So we want it to be able to generate sentences. We want it to be able to speak to us. So this brings us to chatbots. And a chatbot is a very old approach to having a conversation with a computer. So in 1964, MIT proposed ELIZA. And the title of this talk, How Do You Solve a Problem Like ELIZA, is a play on the ELIZA chatbot. Because it is an unsolved problem still. So we still have, we have made great advances recently, but we still have this need, and it's a slightly strange need in places, to talk to computers. We still want to have a chat with them. And I do think that's slightly weird, but it's very useful. In places there are people working on people who are on their own, and there is active research going on about how we can use this technology to give people some feeling of company, and that's genuinely useful. What these are generally used for at the moment is people sitting and playing with them and having weird conversations, often trying to get them to say outrageous things. So that's where the disconnect is for me. We have a genuine use case. There are more use cases like it, but actually at the moment we're a long way away. So 1964, imagine this in 1964. There was no internet. We had no real home computers. Most people hadn't used a computer, and yet there was this program that if you had access to a computer, you could talk to, and it would talk back. So here is a conversation that I had with ELIZA about a year ago. And ELIZA, I almost fell into the trap. I almost said she. So ELIZA, which is a program, so an it, starts off the conversation with, is there something bothering you that you'd like to talk about? So that's a slightly odd but welcoming phrase. Let's have a chat. What's wrong? So I said, well, I'm feeling overworked. Things are getting on top of me a bit. And ELIZA comes back and says, how is it for you to feel overworked? And I said, well, it makes me feel sad. ELIZA says, what about it makes you feel sad? Having had some training since I produced this picture on, among other things, coaching, I sort of recognize this as coaching. ELIZA isn't trying to answer the questions for me. It's trying to get me to answer the questions back. What ELIZA actually is a therapist. But by design. So the questions, the responses that you get are imprecise. They're trying to get you to talk, trying to get you to explain what's wrong. The conversation, so that's 3 statements from ELIZA, 2 statements from me. Any more than that, and we get into weird territory of things no longer making sense. This was developed in the 60s, so well before anything like deep learning. And it was developed using language rules. So there are built-in algorithms within ELIZA that are designed to get to follow the rules of a conversation. So identify maybe the key part. So I'm feeling overworked. So ELIZA will identify that that's a key word and then basically throw it back at me. And that is the underlying way that ELIZA works. Not the most advanced thing. You could use, if I had to do that, I would probably say, look, actually the middle ELIZA sentence is better. How is it for you to feel overworked? How is it for you to possibly feel as well? Are all really common words. So actually it's not hard to imagine that the overworked bit, which is less common, is the important word. That's the key bit. And there are dictionaries, libraries out there, data files out there that you can feed into a program and tell you how common words are. So it's really easy given that sentence to say, okay, well, the word overworked is the least common word there. Let's focus on that and turn it into a question and send it back. I don't think that anyone ever will have had a useful therapy session with ELIZA. I think it's, they're online. I gave a lecture a couple of weeks ago to my students. I realized halfway through the lecture that I completely lost them. And it was because they were all sitting there with their laptops out and they were all chatting to ELIZA while I was trying to teach, which is either brilliant or terrible, but there we are. So it's online. Have a look. as with all of these, I will give you a warning. There is absolutely no telling what they will say. So they might say something offensive, they might say something really outrageous, and by all means have a play with them, but be warned that that could happen. So Eliza in 1964. Things have advanced since then. So we have here Cleverbots. You can't quite see the end of the logo, so let's move it up a bit. Down. So Cleverbot is a more advanced type of chatbot. It's actually developed by someone who lives in Devon. So it's a local developer. He lives up the road in Dawlish and works on various different ways of developing natural language and building these tools. And he's very enthusiastic about having very advanced chatbots. So here's a conversation I had with Cleverbot last night. So I said, so I'm the black questions. What are you up to? And Cleverbot comes back with talking to you, which is a fairly reasonable thing to say because it is. So I say, good answer. Are you enjoying it? And I've just noticed there's a typo there. And Cleverbot says so far, yes. So actually, the typo doesn't matter. Genuinely, I have just literally noticed it. But because of the flexibility of the models that are driving Cleverbot now, it doesn't matter. Cleverbot is built using machine learning. And machine learning is the idea of taking in large amounts of data, using training algorithms to say, what are we, what's the right answer? We're doing predictive modeling. So the predictive model here is, given my last statement, what's the next thing I should say? And we do this in our heads. Sometimes I literally find myself thinking, if you're maybe in a difficult conversation with someone, you think, I don't know what to say here. What should I do? What should I say next? And it's that mechanism that's driving Cleverbot. That is an equally short, but I think a substantially more normal conversation than I had on the previous slide with Eliza. So in the intervening, 40, 50 years, we've come a long way. This works now for a number of reasons. So technology has advanced. So in the 1980s, so deep learning is a current very big thing within AI. And it came of age in about 2012, 2013. However, it's been around since the 1980s. So deep learning is older than I am, which is really quite old. So in the 1980s, they developed these neural networks. They developed these approaches for doing deep learning, as it was thought. And they had two problems. The computational power wasn't there. So, they take, and I've got an example in a later slide, but they have billions of parameters of numbers that have to be identified to make the model work. So we're tuning these numbers to make a model that does what we want it to do. And that's a very computationally expensive process. So in the 1960s, or in the 1980s, when deep learning first came out, there wasn't the computing power to do it. It just didn't exist. You also need a large amount of training data. I mean, millions of examples to make this work. So in computer vision, you literally need millions of photos to train your example on. You need millions of conversations to train this on. And we didn't have that. What we have now are the internet and social media. And we've been having those conversations online for the last 15 years. We've been posting photos, tagging them. So all of a sudden we have the computational power and we have the training data, and suddenly deep learning works. And the people who invented it in the 80s are now very relieved that they've hung on to the thing that they've hung on to for as long as they have. It suddenly worked. And it really was quite sudden and surprising. So we have access to large amounts of data, to training processes, and therefore we have deep learning. And deep learning is able to give us a much better conversational experience than that we used to have. It's also out there for us to use. It's on the internet. You can go to, I think, cleverbot.com, and that will give you the ability to talk to Cleverbot, and it's right there for you. So look, anyone can try it. Anyone with a phone or whatever can chat to Cleverbot. Again, caution is definitely advised. Caution is advised because people go onto these chatbots and try and get them to say outrageous things because it's funny. And, I was a teenager once. I used to do that. I now don't. The problem with it is this is the data that's being fed into the training process. So that's then causing outrageous things to be fed into the training process of Cleverbot or of any other sort of chatbot that's out there. And it makes them outrageous and more outrageous. And that sort of creates a feedback loop, because then the people doing it think, we can make this better. We can optimize our outrageousness. And this goes on and on. In the limit, so it was about 3 or 4 years ago, Microsoft released a chatbot that was tweeting. It was called Tay, Microsoft Tay, and it was deployed online. And within 24 hours, they'd had to switch it off because it was wildly racist. And you know, it was just tweeting these really quite outrageous things. So they had to deactivate it. Go ahead, yeah.
Obviously, it's not responding to a question like these chatbots typically would. Is it working on the same premise, basically? It's just tweeting stuff out at random.
It will try and so people. You can have a conversation on Twitter. So it will react to what people are saying on Twitter. People could tweet it, and then it would respond and say, you know, I'm certainly not going to give examples of what it might have said, but you know, so that conversational element is there. But it was so heavily biased by that sort of content that it did just start thinking, well, you know, that's an acceptable thing to say in that's what I should be saying, and it really wasn't. So so it's very easy to bias these. Please do have a go on these. They're really brilliant, and they are well worth a go. Also, please be slightly aware that it might be, you know, it's not its fault if it says something really, really eye-watering. So why do we want to do this? Well, there are various different use cases for natural language processing, one of which is machine translation. So one of the real early successes, so deep learning 2012 or so, one of the real early successes was machine translation. And it was demonstrated to very good effect when a CEO, I think someone from Google, someone very high up in Google, if it wasn't Google, it was someone in that sort of type of company, gave a speech at a tech conference in China and spoke English. He's an English speaker, spoke flawless English, I assume, to an audience of hundreds of people from China who did not speak English. They had earpieces in, and in the typical way that you would imagine, the speech he gave was translated into Chinese. But instead of having a Chinese speaker listen to the speech and then translate it, it was done by a computer absolutely live, and it worked. And this was their test. I mean, so there's a book I like by New Scientist that goes into the history of AI. And the way it's put across in the book, he stands up and sort of does this big speech and will it work, will it not work? It's a very dramatic thing. There's no way alive, actually, from a software engineering background, that he stood up and didn't know exactly what was going to happen, having tried probably that speech. But the audience didn't know it was going to happen. So when it did and it worked, they were really quite surprised. And it's this sudden revolution that deep learning has brought. Deep learning is thought of as AI. If you're doing AI, if you have a conversation with someone and you say, "Oh, you know, I'm doing AI," they very quickly start talking about deep neural networks, and there is an awful lot more to it than that. And what it's actually doing is, you know, if I have a machine translation model or tool, it will do machine translation. It won't classify what's in a picture. It won't do anything else at all. It is a tool for translating from one language to another. It won't even necessarily translate to languages that it hasn't been trained on. So it's a very, very specific tool. It's very, very good technology for doing that sort of very specific solution to problems, but it won't do anything else. So that's why, I mean, it is currently state of the art because there's an awful lot of effort being expended on it. That's one of the reasons why the robot uprising is not about to happen, because it's fairly difficult to imagine, and I could be completely wrong, and feel free to quote me, there'll be worse things happening at the time. I find it slightly hard to imagine that a machine translation tool will take over the world. I could be wrong. But I've been saying that for several years now and haven't been so far. So we've all used these things. So there's the spoken version of it that they used in the speech. This is much more common. I use this a lot when I'm traveling. I used to travel. Travel is something we used to do before the pandemic. And you'd be in a restaurant, and you might say, you know, does this have nuts in it in Dutch? And I would type that into English, and it would turn it into Dutch, and they would know what I was asking. So I've used that a lot, and it is something that's just there, something we just use. It's not a thing you think about anymore. So, sentiment analysis is another example of what we might like to do. What does the phrase "that film was bad" mean? I know what it means to me. To me, that means I won't waste that 2 hours of my life again. You know, it's a terrible film, mustn't watch it, recommend no one looks at it. If you're significantly younger than me, that might mean that was a brilliant film. I'm definitely watching that again. Other examples, sick. If you're of my generation, it's generally not good to be sick. If you're of younger people's generations, it's pretty good. So we use these words, we have these words, and they have very different meanings based on our own context, based on our own experience. I could probably be persuaded to say something's bad. I don't think I'll ever say a good thing. So we need the computer to understand that. If we're giving Alexa instructions, you know, you can say, play me something random, play me something good. And it'll play you something random. I'm not convinced it'll play you something necessarily good, but it needs to understand what I mean by good, if that's going to work. So I need to have some AI then. I need to have some software in my tool that says, okay, what's the sentiment behind this? Given the words that are used, what's the actual meaning here? Sentiment analysis is exactly that. So something that computers are very bad at and that I'm very good at is sarcasm. And I'm a deeply sarcastic person. And someone will ask me, what do you think of that? And I'll say, well, that was wonderful, wasn't it? And you can tell from my tone of voice that actually I'm really unimpressed. It's like the sort of Britishness translation things you see where you say, oh, well, that's interesting. And you actually mean absolutely not. So we need something that's going to do that for us. We need something that's going to say, okay, I know what they said, but actually this is what they mean. And that's a really hard problem, because it's a really hard problem to say this is what they've said. So if we're going to struggle to understand the actual words we've used, understanding the sentiment is even harder. It comes down again to having lots of examples. And what we need here are people to basically mark up what they meant or mark up what people mean. So large bodies of text are an example. Go through it. Okay, we've got a sentence, that film was bad. And someone will give it a score on sentiment. You might say have a score -5 to +5, where 0 is neutral and -5 is terrible, +5 is positive, is really good. Give it a score. We can then use deep learning or machine learning or any sort of AI learning technique to try and learn, given a sentence and given the context that sentence sits in, what's the score? Can we predict that score? If we can predict that score, then you can say, okay, they've said this, I think that's a good thing. And you can then respond in that way. You can have your system set up, your software, your home assistant, whatever it is, set up so that it says, okay, here is this and it's good, or here is this and it's bad. And they'll be able to deal, it'll be able to deal with what you're saying. So that's a really hard problem. We have people at the university here who work on that and try and create new and innovative ways of doing sentiment analysis. GPT-3, so bringing it bang up to date, is a language model based on deep learning. So it's a deep learning language model. I've already said everything that goes on, a lot that goes on in AI at the moment is based on deep learning. It's almost dull at times. There's so much more to AI, but it's the big thing of the moment. So GPT-3 is a language model that produces natural language, so it will produce text. You can give it an outline of a story and it will go off and create a short story for you. You can generate source code. So if you're into software engineering, you can give GPT-3 some information about what you want your program to do, and it will generate some limited amounts of source code. It's not anywhere near at the point where those of us gainfully employed doing software engineering have anything to worry about, but it's interesting that they're starting to produce it. It's actually an easier problem, I think, than generating natural language. Source code requires very specific syntax to be followed, much more specific than I'm using now. English has syntax and grammar, and I'm probably riding roughshod over it and just saying what I want to say. If you do that with source code, it won't work. Your program will not function. So it's an easier challenge in some ways to produce. That's now been licensed by Microsoft. They are apparently the only people in the world with access to the actual model. There is an interface you can use online that you can send messages, send requests to, and it will give you stuff back. But backward engineering that model is now firmly in the Microsoft domain. That has 175 billion parameters to tune. So that's what the model is based on. So basically what Microsoft have licensed are those 175 billion numbers. And that is the model. If you don't have those numbers, you don't have the model. And it's an odd thing to be able to license, but actually training that model, getting it there, requires gargantuan amounts of data, requires gargantuan amounts of processing power. So it's a really useful thing for them to have licensed and then be able to sell on to their users. So let's stop thinking about deep learning for a second and go back in time to 1950. So we're now back before the Dartmouth conference. And the people at that conference were not the only people who were thinking about language and intelligence. So Alan Turing, who hopefully everyone's heard of, currently on the back of, I think, £50 notes, so not the most accessible way of finding out about him, but led large parts of the effort at Bletchley Park during the war, well known for designing machines that helped to crack the Enigma. He also did this. He was really, for someone who only really had a short life, he was incredibly productive. Proposed in 1950, the idea of a thinking machine. So let's think about that for a second. Didn't really have computers at that point in the way that we have now, but he recognized 72 years ago that we might want to have intelligence. We might want to then also test for intelligence. So I've been talking about AI. I've been talking about having, intelligent machines. I try and avoid intelligent machines actually because they're not always that intelligent. They're doing some number crunching and they're using slightly intelligent methods to get there. But we could have another hour entirely on our machine's intelligence. That's the question Alan Turing wanted to answer. So he wanted to find out, could we have a computer or a machine at that point that you can have a conversation with and that you don't know is a computer? So if you can't see what you're having the conversation with, can you fool a human into thinking they're talking to another human? And if you can, then that's intelligence. Because Turing recognized that the language problem was actually one that required intelligence to solve. So if you can understand what I'm saying, you must be intelligent in some way. You may all like listening to this to think that that's true. I think it's a measure of intelligence. I think there are others. And actually, if you look at the topics that were proposed at Dartmouth a few years after this, each one of them has some sort of Turing test type strategy you can take. So computer vision, for example, can you understand what's in the image? Can you write a piece of software that will say, describe it, not just say, this is a picture of David, but describe what's in the picture, write a caption for it. So Turing proposed this test, the Turing test, and you have two people and a computer. So we have two people here, a questioner and an answerer. And the idea is you're going to have a conversation. You're going to pass information, messages, basically, back and forth. You also have a computer that is receiving the same messages and is going to respond as well. Crucially, the questioner cannot see the other person or the computer. All they receive is basically, think of sort of sealed envelopes that are coming back. That's very 1960s. Let's think about maybe messages that are appearing on a screen. And they appear at the same time. They're typed, so you can't say, well, that's handwritten, that's definitely a person. All you have is the text. And the challenge is, can you work out which is which? So Turing said in his paper, he was very, very, very specific, actually, given that he was at this point 50 years away from his prediction. He said that by the year 2000, 30% of questioners talking to a chatbot or an AI would be convinced that they were talking to a human. So 7 in 10. sorry, 3 in 10. That's a fairly low number. It's less than 50%, less than half. Actually, it was nowhere near accurate because you've seen the conversation with Eliza. It's really easy to spot that these things are not human. You might have the first few lines that are pleasantries, and then it'll say something weird, not necessarily offensive, but it'll just say something strange, and you'll think, how did you get to that? If I had a penny for the number of times a chatbot has proposed marriage to me, I would be a very rich man and also a very married man. They're just obvious to spot once you have a chat with them. So Turing thought we'd get there. He thought that by the year 2000 we'd have this benchmark met. Sadly, he was wrong. Versions of the Turing test, though, have been very popular. We have these chatbots there on the internet. People are really developing them. And like elsewhere in the AI community, we're very keen on competitions. So you can have a competition. It really drives the innovation forward. The first time deep learning worked was at a computer vision conference that was running a competition. And they really thought that the support vector machines, which were the tools of the day, would win the competition they had previously. And this deep neural net came in and just blew everyone else away. It wasn't like a marginal increment. It was quite a step forward. So other competitions that are held are versions of the Turing test. And here we have an example of a chatbot that has, well, caused a controversy. So in 2012, Eugene Guzman convinced 29% of the people, of the judges that were at this version of the Turing test, that it was actually a 13-year-old Ukrainian boy. So that's the sort of the context for this chatbot. He's set up to be a 13-year-old Ukrainian boy. That, from a development point of view, from a competition point of view, is a clever thing to do, because at 13, perhaps his language isn't as advanced as it would be, and he's a non-English speaker having English conversations. So actually, you think your English isn't great. So perhaps that's why you're saying something strange. What actually is the case is that it's not such a wonderful chatbot, but it's obscured by the fact that you've put this veil of him being 13-year-old Ukrainian boy. People thought actually 29% is pretty close to Turing's claim. So this, I think, was something like his, it was for the 100th anniversary of his birth. They ran a special Turing test. 2 years later, to mark the 60th anniversary of his death, they ran another one. And this time, Eugene Guzman, who'd had the intervening 2 years to get better, convinced 33% of the judges that it was actually a person. And this was big news at the time. I mean, it was on the BBC News. We have AI. AI has landed. We have a chatbot that is convincingly human. And people who are expert in the area sort of turn around and say, well, hang on a second, we really haven't. We've got something that's expertly passing itself off as intelligent, and it's doing it behind this veil of being a non-English speaker in an English-speaking competition. So not surprisingly, the competition hosts were very excited and had press releases and all sorts of things. Generally, it's considered that Turing's 30% by 2000 benchmark still hasn't been met, because it needs to be done in a sort of on a level playing field with everything else that's in competition. Eugene is no longer online. So a year or so ago, when I took the screenshot that you see there, I did have a hunt around to see if I could have a conversation with him. He's no longer there. I'm doing it again. It is no longer there. It's a very easy trap to fall into. So we've made lots of progress, and we have lots of things that we can point to. We have these chatbots, we have computer vision tools, we have really successful and useful AI. There's a tool that the NHS use that does breast cancer classification, and it classifies mammograms to a higher level of accuracy than a human doctor. It's not to say the human doctor is not then involved, but they use it for prioritizing how they look at cases to make sure that the ones that are most likely to have health problems are seen earlier. That's all to say there's still an awful lot to do. So here at Plymouth, we work extensively on solving cutting edge AI problems. So we're trying to push the boundaries of what we do. We're developing new machine learning techniques. We have an extensive field of expertise in robotics. I talked about the 175 billion parameters. Finding those is an optimization problem. People work on techniques for doing that so that you don't need the massive amounts of computational power. There are people working on computer vision, and we have people who are using AI who are using the way the brain works to inspire the next generation of computing architectures. So there's a lot of it done. A lot of AI is working very efficiently, and we can use it. And it touches everyone's lives. When I do my first lecture of my AI course, the first thing I do is who's touched AI today. And if not every hand goes up, then I say, well, I'm afraid you've got your first thing wrong with the module, because everyone will have touched AI at some point today. Everyone on Zoom, for example, there'll be AI monitoring the call and making sure that the bandwidth is acceptable and that there are no errors, and maybe even correcting the odd frame error that comes through. So it's everywhere. Our students are working on these problems, and we're working on them, and the AI community in general is working on them. So it is a very exciting time to work in AI. There's a lot going on. If you look at the industrial strategy published by the government in 2017, it was the first of 4 grand challenges that stands in the way of a really booming economy is having better AI. And they seem, for reasons of boredom, I suppose, to like pumping out documents every year that say, we must have more AI. So we must have more AI, and that will, I think, make the world a better place. So with that, I'll stop talking, but I'll finish by saying that we have machines we can talk to. We have Alexas. Sorry again for the people online whose Alexas just went off. And these things can provide us with considerable benefits. They're really useful tools. They are moving from sort of being curiosity things that we like to play with, chatbots that people like to say outrageous things to things that are genuinely useful tools. And they are making, I think, the world in places a better place. We have the Turing Test. There's a lot of thought about whether or not the Turing Test is the right measure for the job. I think it's a very good measure of whether or not someone's having a conversation with you. It's open to abuse, as I said. So we have the Gooseman affair, but I think it has its place. And people are looking, okay, well, can we apply this elsewhere? Can we use it in computer vision? Can we use it in knowledge representation tasks? And we're making good progress, but there is still an awful lot to do. So I would like to leave you today with the thought that we've done very well, but there's more to do. So jump in and help, and we'll all get better together. Any questions?
Can I ask a question? I don't think the Turing Test, what the relationship between that and, so there's a lot of talk about artificial general intelligence.
Yeah.
And there seems to be different views on whether we can achieve AGI or not.
So AGI is an artificial intelligence walked into you in the street and you don't know that it's an AI. And that's years off, I think. I believe we can get there, but I don't think that we'll get there in the next 10 years, for example. What we work on generally is soft AI. So we'll say, okay, I've got this particular problem. I need to translate language, and I will build an AI tool that does that. And no one's going to be fooled into thinking that Google Translate is a real person. So I think the Turing Test has its place. I think it is, as I say, conversationally. If I was an AI, if I was reading an AI script, you might be convinced by what I'm saying that I'm a person. I think that's a useful thing to be able to tell. I think that's useful from a trustworthiness and privacy issue, actually, because there's a lot going on. If you think about generative adversarial networks, deep fakes, they're really quite a harmful thing. And that is a case of generating content where people haven't said the things that they're saying. And being able to spot those is really important. There was one, I don't know if it was a deep fake or it was just a really, really bad video production, but this week there was on Ukrainian television a picture of, it was a deep fake. I haven't quite got around to watching it probably yet. Yes. So this, for anyone online who isn't aware, is President Zelensky, I don't know if he was capitulating or what he was doing, what he was saying. Lay down their arms, yeah. So he obviously wasn't going to say that. I mean, that flies in the face of everything we've seen him say for the last month. but there is this video on the internet. Now, having seen a picture of a screen cap of it, his face is a very different color to his neck. So that's an example. That's a one way of telling. And actually, with deep fakes, that's the best way of telling. You know, does this look right? Is the video? You know, you get strange movements of the mouth. You get tones, lighting that's not quite right. So there you have a more advanced version of the Turing test. Are you convinced by this? That's really what the Turing test is asking. So I think it's very important for AGI. It will be when we get there, but I don't think we're at the point where we're that close to it. But it's very important now that we have mechanisms like that that say, I can tell the difference between something that's artificial and not, and that we train people to do it as well. It's not, this is a Turing test, it's our annual competition. It's, I'm a user of the internet, and I need to be thinking, is this genuine or not? You know, that's an obvious fake because it's not something that he would in any way say. But you can imagine someone saying, using the same technology to say something that's slightly off-piste, but not that far that it's unbelievable. So I think it's incredibly important. I think it's important that everyone knows that. Jacob.
I've also heard a story, apparently in South Korea, apparently there was a news presenter who actually temporarily left the show, but the studio used the deep fake.
Really?
To continue presenting.
I did not know that. That's my afternoon of investigating taken up. I'll have a look for that.
Yeah.
That's really interesting.
I don't know all the ins and outs, but I've heard about it.
I mean, one of the real uses is so they put Carrie Fisher into the last Star Wars film because they had bits of footage they'd not used elsewhere. Well, if an actor like that passes away during production, deep fake them in. You know, that's one of the things they'll use this for. Yeah, it's yeah, one of the, I mean, you can have a conversation with Henry VIII. May or may not be something you're interested in doing. Yeah. I don't see any comments in the chat.
I know it's sort of on the computing curriculum in schools. Part of the spec is around sort of information accuracy and digital literacy, and I think it's important teachers keep pace with how fast technologies evolve. I know when I was at college, I was shown that you could use a tool to remove spots on Bossy magazine.
Yeah.
And we were all amazed that that was happening. And you think how far it's come.
Exactly. And deep fakes are only about 5 years old. So actually, to have come this far in 5 years, where will they be in 5 years' time? We're not at the point of AGI, but it's one of the reasons that it's so important that we have all the ethical conversations now, so that when we do get there, we don't go, oh, good Lord, this is happening, what do we do about it? And people, it's probably, I think, one of the most important parts of the computing curriculum. You know, people have to be aware that this is as dangerous, because kids are out there, you know, I see them on the train there on Facebook, they're posting pictures, they are feeding this machine with the training data for it. You know, anyone who's posted video footage of themselves on Facebook could be deep faked. I say that to students in front of 100 or so students when the lecture's been recorded, and at the back of my mind last time I said it was, you know, they've got hours and hours of footage of me, and I'm normally standing in front of a lectern from the same camera. It's ideal footage. So that's a thought that's festering currently. But we have to trust people. So, yeah. Well, yes, there we are. So that's 10:56.
Wow.
Am I on time?
You are absolutely on time.
Perfect.
Thank
Well,
you very
thank you very much for having me. I hope it was interesting. Thank you online.
So yes, thank you. So for those online, before David turns it all off, the next session is at 11:30 on the same link. We are back here. Oh yeah, you've got the camera. We had the camera up there last time.
It's there.
Yes. So yes, 11:30 on this link for the careers session, and we're back in here with Pippa and some of our graduates. And that's the afternoon. But there are more pastries outside. Please have pastries. So yeah, I don't know what's in the chat. Someone.
Georgia.
Okay, Georgia. Right.
Yeah.
Okay.
Thank you
Let's
very much.
draw that to a close. Thank you. Thank you for speaking to the hordes.
That's all right. Hang on.